Welcome to David Alexander Maths Tuition. This is chapter 4c, which is using the binomial expansion with partial fractions. Okay, so the first part of this question is just writing some algebra as partial fractions. So hopefully this is fairly familiar to us. So 4x plus 7 over 1 plus x, 2 plus x can be written as a lot over 1 plus x plus b over 2 plus x. And we can write that as a lots of 2 plus x plus b lots of 1 plus x equals the numerator, which is 4x plus 7. So let's let x equal -2, so that would be 0a minus 1b, and that will equal -8 plus 7 minus 1, so therefore b is 1. And now if we let x equal -1, that will mean there's 0 b's, and we will have 1a equals 4 times -1 is -4 plus 7 is 3, so a is 3. So what we have is 3 over 1 plus x plus 1 over 2 plus x. Okay, so now that we've expressed it as partial fractions, we can do our binomial expansion. So the first one we can write as 3 lots of 1 plus x to the -1. Now luckily the number is 3, so that's 3 lots of 1 minus x plus -1 minus 2 multiplied by x squared all over 2, and -1 times -2 over 2 is 1, so that's going to be 3 lots of 1 minus x plus x squared, so 3 minus 3x plus 3x squared. So let's just park that for a moment. Okay, so remember we do need to add these together in a moment. So this is 1 lot of 2 plus x to the -1. Well, that 1 can disappear, but we've got a number which is not 1, it's 2, so we're going to write there's 2 lots of 1 plus 1/2 x to the -1, and we can write that as 2 to the -1 times by 1 plus ½ x to the -1, and 2 to the -1 is a half, so that is a half times 1 plus 1/2 x to the -1. In other words, it's 1/2, 1 minus 1/2 x plus -1 times -2, 1/2 x all squared over 2, and the -1 and the -2 will cancel out with that 2. So what we're getting is 1/2, 1 minus 1/2 x plus 1/4 x squared. So expand the brackets, we're going to get 1/2 minus 1/4 x plus 1/8 x squared. Okay, so now all we need to do is add them together, and 3 plus 1/2, that is 7 over 2. We have here -3 plus minus 1/4, so -3 minus 1/4, so that is -13 over 4x. And finally we've got 3x squared plus 1/8 x squared, so that is 25 over 8 x squared. There we go. So we have done our expansion as far as the x squared term. Now the values for x for which the expansion is valid, so here the binomial expansion is on the 1 plus x to the -1, so here the modulus of x must be less than 1, and here it's a half x, so the modulus 1 of a half x must be less than 1, so therefore the modulus of x must be less than 2. So we'll go with the more conservative one here, which is the modulus of x must be less than 1. Okay, so this question, well, it's a tricky one, but the main thing is just making sure we understand how the partial fractions work. So we know that this is going to be a over 5 plus x plus b over 5 plus x squared. So what we can say is that a lots of 5 plus x plus b equals 5x plus 19. So let's let x equal -5. So therefore what we have is b is -25 plus 19, and -25 plus 19 is -6. So b is -6. Now let's let x equal whatever we want. Let's go with a 0, nice and easy. So what we have is 5a plus b, we know that b is -6, equals 5 lots of 0 plus 19. So therefore 5a is 25, so A is 5. So as partial fractions, we have 5 over 5 plus x. I'm going to put the minus in the middle there, minus 6 over 5 plus x squared. Now, it's possible some people might not have understood how we did the partial fractions there because we have the denominator squared, in which case maybe you just want to go back and just revise your partial fractions. So we've done the first part there. I'm just going to clear all the ink so we can have some space for the next bit. Okay, so what we can do with these partial fractions, I can write it as 5 lots of 5 plus x to the negative 1. So I'm just going to deal with the expansion on this one first of all. So that is 5 lots of 1 plus 1/5 x to the minus 1. Remember, we can't handle this 5, we have to factor it out. And 5 lots of 1 plus 1/3 x to plus 1/5 x to the minus 1 is the same as 5 to the minus 1, which is a fifth, times 1 plus 3x to the minus 1. So if this 5 is becoming a fifth, let me just write this a bit more clearly. So first of all, this is 5 lots of 5 to the minus 1 multiplied by 1 plus 1/5 x to the minus 1. 5 to the minus 1 is 1 over 5, and 1 over 5 times 5 is 1. So actually this tidies up not quite nicely to 1 plus 1/5 x to the negative 1. So the expansion will be 1 minus 1/5 x plus minus 1 minus 2 1/5 x all squared over 2, and the negative 1 and the negative 2 cancel with a 2. So we've got 1 minus 1/5 x plus 1 over 25 x squared. So let me just park that there. I'm not going to stress about the subtracting just yet. I am going to stress about the 6 lots of 5 plus x to the negative 2 though. So that's 6 lots of 5 lots of 1 plus 1/5 x all to the power of minus 2. 5 to the minus 2 is 1 over 25. So we've got 6 over 25 lots of 1 plus 1/5 x to the minus 2. So that is 6 over 25 times 1 minus 2/5 x plus negative 2 times by negative 3 1/5 x all squared over 2. So that is, if I just take it up here, that is 6 over 25, 1 minus 2/5 x. So 2 times 3 times a fifth divided by 2, or 2 times 3 divided by 5 divided by 5 divided by 2 is 3 over 125 x squared. Expand the brackets, we get 6 over 25 minus 12 over 125 x, and this is plus 18 over 3125 x squared. Okay, so remember we are subtracting this stuff here from this stuff here. So 1 take away 6 over 25, that is 19 over 25. Minus 1/5 x, take away minus 12 over, in other words, plus 12 over 125 x is minus 13 over 125 x. And finally, 1 over 25 x squared, take away 18 over 3125 x squared is plus 107. And the denominator is still 3125 x squared. So A is 19 over 25. B is actually minus, not plus, but that often happens, minus 13 over 125, and C is 107 over 3125. So state the values of x for which the expansion is valid. Well, on both occasions it was 1 plus 1/5 x, 1 plus 1/5 x, so therefore the modulus of 1/5 x must be less than 1, so therefore the modulus of x must be less than 5. In other words, it only works if x is between minus 5 and 5. So quite a tricky one, that one, a lot to do, very messy, and also some pretty difficult partial fractions there.